Support for today's Heat Treat Radio episode is provided by Heat Treat Bootcamp. Find out how to enroll in this basic training at www.heattreattoday.com/bootcamp. Welcome to Heat Treat Radio. Whether you're listening to us or tuning in via video on heattreattoday.com, we're glad to have you. In this Heat Treat Radio episode, we're hearing about a never-before-seen combustion system tuning technology as host and Heat Treat Today publisher Doug Glenn sits down with Justin Dzik, Manager of Business Development, and Ben Witoff, Manager of Data Engineering from Fives North American Combustion. Let's hear from the experts as they describe how this system will save time, money, and personnel, and can be adapted to virtually any furnace system. Let's take a listen.
This is kind of a new technology that I haven't seen it before in the market. We're going to be talking about combustion system tuning. And we have here with us today Justin Dzik from North American Combustion and also Ben Witoff. Justin is the Manager of Business Development there in Cleveland. Welcome, Justin. And Ben is the Manager of Data Engineering. So we're going to hit on, I think, what's a pretty interesting new product that you guys are developing. When I first saw about it, first off, it's a great name, which I will mention here in just a minute. But when I saw what it was, I thought, I have not heard of anything like this before. So I think our listeners and viewers will find it of interest. So the name of the product, just so we don't have to wait too long, is called the Certifier or Certifier. So that's first. But before we get too far into it, Justin, if you don't mind, can you give us just a brief background about you?
Absolutely. So as Doug already said, I'm the Manager of Business Development, and I've worked at Fives for 15 years now in various different roles, primarily focused on the forging and heat treat markets, doing uniformity tests. And really, that's kind of why this product is so close to us. So Fives North American, we're a company that's been around for about 100 years, located in Cleveland, Ohio. And we produce combustion equipment, obviously, but we also do turnkey systems. We do furnaces, direct fired furnaces, obviously, for the forge heat treat, but we also supply combustion equipment for pretty much every industry that needs heat, which is quite a bit.
Yes, yeah, for sure. And I would like to mention also, for those of you who are old timers, somewhat like me, Fives North American Combustion should be recognizable. The old company name was just North American Manufacturing, I believe. They're in the Taj Mahal on, what is it, Grant Street or something like that in just south of Cleveland, downtown Cleveland. Right. So yeah, so that's the little bit of the heritage. So Ben, how about you? If you don't mind, give us a quick blurb about yourself and your role there.
Yeah, sure. Thanks, Doug. So I've been here just about 10 years. My 10-year anniversary is going to be next year. I've worked in various R&D roles since I've been here. Started as a burner designer, worked with FEA CFD modeling, moved into thermal processing engineering. And then just a few years ago, I started the data engineering department here so that we could try to augment our combustion and industrial equipment with sensors, with IoT, with data, with smart engineering, and just to try to take it a step further. So that's what I've been working on here.
Yeah. Industry 4.0, IoT, all that stuff is very, very interesting. That's what caught my attention on this thing. So Justin, without going into detail, okay, so if someone only watched the first 2 minutes of this podcast, from a 30,000 foot view, what is Certifier and why should people care about it?
So the Certifier is, as you already stated, automated tuning device for temperature uniformity certifications. So I think pretty much everybody that's going to watch this podcast is probably going to know that they can be extremely timely to do, take a lot of time and take a lot of intelligence to actually tune the process. And this device takes all of that and does it all itself. So it does all the automated burner tuning, all the valves adjustments. It locks it all in and tunes it for whatever class uniformity you really need.
Yeah. And I did want to hit on that too, because we're talking about trying to tune a furnace, tune the combustion system on a furnace so that furnace is running, first off, optimally, not wasting energy, correct? But also we're talking about trying to make that system uniform, trying to make the work zone uniform inside that furnace. So again, most people will already know this, but it's always good to hit on some basics here because there may be people listening that don't know some of the basics. Why is this work zone uniformity, the area inside the furnace, why is it important that it be uniform? And then if you can, maybe hit on what we mean when we say furnace classifications.
Sure. So obviously it's important because the parts that are going into these furnaces can be used for a variety of applications, like everybody knows. Aerospace being a primary part class that's going in. And because of that and the metallurgy required, everything needs to be within a certain temperature band in order to get the same, metallurgical properties after they forge it or heat treat it or whatever. So it's extremely important to make that work zone as tight as possible and as consistent as possible. And as we can all imagine, having a work zone about 3-4 feet away from a fire, essentially a live fire coming out of a burner, is extremely difficult. As you said already, there's classification, there's different codes that govern the work zone classifications, like AMS 2750 revision F is obviously the most recent one. Rolls-Royce has their own. Pretty much all the aerospace suppliers have theirs. So the classifications really govern how tight the uniformity band has to be in that work zone. So there's class 1, which is basically plus or minus 5 degrees Fahrenheit anywhere in that work zone. And it goes all the way up to class 6, which is plus or minus 50. So much more lenient. Obviously, class 1 is the hardest, probably all heat treat stuff. Class 6 is probably some heavy forgings.
Yeah. So as we move up the furnace classifications, as we move up from going plus or minus 5 up to plus or minus 50, which might as well not even have a furnace classification for that, right? At the lower classifications are where it's really critical that any type of heating source, whether it be electric heating elements or combustion, be well tuned, because you want the whole entire that whole entire section to be, the whole entire work zone to be uniform. But we're talking specifically about combustion tuning. How typically, and Justin, I'll address this one to you, and then Ben, hold on, we're coming to you. Next question, I think. So how have combustion systems typically been tuned in the past? In fact, I would say probably 99% of them are still tuned even now. And what are some of the major issues that we run into in the way we're currently doing it?
Yeah, so obviously there's a variety of complexity of systems out there. There's furnaces still in operation that we put in 1960. So the amount of valves they have on there, they're probably more manual valves. So there's a lot of manual tweaking of things going on right at the burner. The more advanced systems now up to today have automated valves, but you're still doing manual adjustments in a PLC probably that you're trying to tweak. And I think everybody knows, and I think Ben really likes to use this statement, it's a game of whack-a-mole. You adjust a burner here and it goes out of compliance over here and you run over there. I mean, I've been on hundreds of surveys where I'm running around the furnace trying to watch my temperature map that I have in my hand. And it can get very tedious. And it takes a lot of know-how and a lot of experience to, I believe, tune these furnaces.
There is, I suppose, to a certain extent, there's an art to it now, very much dependent, I'm guessing, on your specific furnace, your specific burner configuration, and what mode of combustion you're using, whether it's pulse fire or whatever, right?
Absolutely.
All of those things are the art of combustion. Kind of takes us back to that black art that heat treaters are trying to avoid, right? Where really you kind of got to figure it out each one individually. So Certifier is basically going to help us eliminate that. So Ben, if you don't mind, Certifier, how does it work? How does it work? And why is it better? And what kind of results do you think we can get in the sense of amount of time spent trying to tune a system and uniformity?
Sure. Yeah. So as Justin mentioned, I love using that term whack-a-mole. I think it's a great way to describe it. It's a great way for people to understand. You bop down one of those thermocouples, you get it to the right temperature, and then the next one popped right back out. And the reason that happens is because these furnaces are nonlinear systems. When you look at the inputs and you look at the outputs and you try to model it just from a purely physics or mathematical perspective, it's not something that can be tuned linearly. You can't just adjust a valve and then adjust the second valve and expect all the adjustments from the first one to carry over. You're constantly throwing one thing out of whack when you bring another thing in. So, and then you also touched on this with your other question. There's so many other factors that affect the uniformity of the furnace. If we built 5 identical furnaces in our factory and got all the burners set up identical and then we shipped them out to 5 different locations, they'd all be different, completely different, because it's the humidity on that day, it's the temperature, it's the elevation that it's installed, it's whether or not the facility is indoors or they have their garage doors up. There's so many different factors that affect it. It's the humidity when we mix the refractory on that day that affects it. So you can't just tune it and forget about it, ship it off. So it needs to be done on site. And today, it's kind of that art. It's someone that's highly trained. They have years of experience to do it, and they're the furnace whisperer. They can figure out exactly how they get those systems into tune. So what we did is we took a step back and we said, how can we try to approach this mathematically? So first thing that we identified is we cannot be adjusting one at a time. You don't adjust burner 1 and then look at the temperature readout and then adjust burner 2. We can't do it that way. So we said we have to figure out how we can model that 3D space, those inputs and those outputs, and that relationship between them. And that's the fundamental nature of what the certifier does. So we use this phrase response matrix, and this is the way that we've created this, you call it like a virtual map of the furnace. It maps all the inputs, those heat sources, to all the outputs, those thermocouples in the work zone, that temperature measurement point. And what we do is we go through this training phase for every furnace where we modulate our burners, we change the firing rate in a known way for all of the burners, and then we measure exactly how those temperatures of those thermocouples in the work zone change. And the way that they change, the speed at which they react, the amount of time it takes to heat up and cool down, and the exact 3D map of where those thermocouples are and how they react to each burner and where those burners are, is what this response matrix is. And the beautiful thing about the math behind it is you can solve the equation forwards or backwards. So it's easy to modulate a burner. It's an independent variable. You can tell it exactly where to be, and then you don't know where the temperature is going to be, but you can measure it once you modulate that burner. So that's our equation. We build the forward equation, and then the beauty of the certifier is we just flip it backwards. We solve it the other way. We say, where are all our thermocouples today? What's our survey temperature? All right, well, this one's 5 degrees hot, this one's 20 degrees cold. So you have all of your delta T's. And then you say, well, if this is my array of delta T's, then divide by the response matrix, what's my array of delta burner adjustments? So it solves for all the burners simultaneously, takes all the adjustments into account, gets rid of that whole whack-a-mole game, and it tells you burners 1 through however many you have need to be adjusted X% up, X% down. You do the adjustments, it looks at it, says, is it good enough? If not, make another adjustment.
Yeah. Very interesting. Very interesting. So this is all done through algorithms and things of that sort, I assume, huh? The secret sauce.
Right, exactly. So it's some fairly simple math, but it's this matrix math where we're trying to model multiple inputs and multiple outputs, and we're trying to map n inputs to m outputs. So it's not necessarily linear still, but we're making these linear approximations for a nonlinear system.
Okay, so I want to create a persona for you and ask you a question about the capabilities a little bit. So I'm a person who owns a class 4, 5, or 6 furnace. It's not all that precise, right? Plus minus 15 or upwards. It's an older system, right? I've got old burners on there. I've got old valving on there. In order to use the certifier, do I need to update those burners and or valving so that it can be precisely tuned, or does the certifier work on, you name it, any type of current combustion system? Ben, why don't we go to you on that?
Sure. So I guess I'd say yes and no, and I'll get into the details on that because it can be kind of a confusing or irritating answer. Yes, I'll start with that because the fundamental algorithm really doesn't care that it's a furnace at all, doesn't care that it's a cube, doesn't care that there's X number of burners or whatever dimension. The fundamental algorithm is simply that you map inputs to outputs, and they could be any different size. They don't have to be the same size. And then it allows you to solve it backwards. So the fundamental algorithm the piece that is the heart of the certifier, can absolutely work on that furnace. The reason I said no is because the first piece of technology we're trying to tackle with the certifier is a more advanced PLC controlled system. So the way that we do tuning today is we use bleed valves, actuated bleed valves per burner on our furnaces so that we can make that fine tuning automatically through a PLC adjustment. So because the PLC can control those actuated bleed valves per burner, it's really simple for a device to just simply plug in with the data cable and then immediately take over the furnace and make these adjustments automatically at the push of a button. So that's the first tier of furnace technology that we're trying to tackle, that we're trying to release a product for. And what we're working on after that tier, our lower tiers, are furnaces where customers are wanting to retrofit to a bleed valve system. And then finally, after that, are customers that are unwilling or don't want to upgrade to that retrofit system. Because no matter how you make that adjustment, the easiest way is a bleed valve if you already have it. But no matter how you make it, if it's a limiting orifice valve and it's a technician with a screwdriver in his hand, it's the same algorithm. The only difference would be the certifier HMI, maybe it prints out a sheet of paper that the guy can walk around the furnace with, or he's carrying an iPad, and it says, burner 1, quarter turn right, burner 2, eighth turn left. The same thing. He can make them, one after the other in series because the solution itself is still a parallel solution.
Right. So so obviously it's going to take more time, and there's more manual interaction there with that latter example you were giving.
Right. But it's certainly not more manual than they would tune it without the certifier. Right. And it doesn't take that furnace whisperer technician to get that done. Right. Anybody can read that sheet and make the adjustments that it tells them to make.
Right. Because it sounds like with yours, even if you're doing the adjustments manually, let's say in your latter example, you're going to go out and you're going to make an adjustment to all 12 burners on your furnace and come back and see how that goes. Right. Whereas if you're, as you say, the whack-a-mole furnace whisperer, he's going to go out, adjust one, come back, see how it goes, go back out, adjust another one. So that makes some sense. Okay. How about installation of this thing? You mentioned data cables and things of that sort. How complicated is this thing to install, and how much time?
Sure. So starting with the first tier of customer that we're trying to talk about here, if there is an existing furnace, if it has the panel that we built for this customer, if they have these bleed valves with actuators on them talking to the PLC today, if we were to walk into that facility, we would have a box that's literally plug and play. It needs power, it needs data, and then your HMI has a green go button on it. So it's something that we would pre-configure because we'd understand the tags inside of the PLC, how to communicate to all the valves. It would actually be that simple. If it was built by somebody else, or it was an older panel, or we didn't know how the PLC worked, it would probably take some time for us to understand it from the controls perspective so that we could get all of the tags coded properly. But that's not any time where the customer is not running. They're still running. We're just in the background, just reading some PLC information. And then finally, if this is a customer that wants to add that equipment, if they're looking to upgrade, if the equipment's older, or maybe they're a class 5 today, but they really want to be class 3 or maybe even class 2, we would probably suggest with or without certifier to upgrade to those bleed valves per burner. We think we can get better control with that. Yeah. And in that case, maybe the customer has to shut down the furnace for a week while we do the installation. And then once it's installed again, it would be really that simple as a plug and play device with a data cable.
Okay. All right. Yeah.
We'll return in just a moment to hear about how you might adapt the system to work at your plant. But first, we want to see you in Pittsburgh this October 2022. Heat Treat Bootcamp is a great opportunity for new hires and old hires who want a refresher on how the North American heat treat industry works. We're talking the main players, products, processes, markets, and materials in the North American heat treat market. That is, who are the main equipment and service suppliers? How do they interact? What products are they selling? What are the most popular processes in heat treat? What are the markets that heat treat is most important to? And what materials are most often heat treated? Yes, it's comprehensive, but it is not overly technical. When you go to heattreattoday.com/bootcamp, you'll see that this basic training will prepare you to walk and talk the industry and do your job well, whether you're just starting, moving into a new position in the industry, or simply needing a refresher. Register for the 3-day training in Pittsburgh at www.heattreattoday.com/bootcamp. Now back to the episode.
Justin, I've got a question for you now. I can imagine that some of the viewers, listeners are wondering, yeah, I've got a combustion furnace. I'd like to do this. Does it make sense for my furnace? Are there any systems out there that you can think of, any furnaces with combustion where the certifier would not make sense? I mean, are there any applications or anything along that line?
Honestly, I think that if you need to comply or certify your furnace to any uniformity standard, the certifier could definitely help. As Ben stated, there's different tiers of the product and how it would actually be from the customer experience, from an totally automated state to a more manual, more of like a certifier as the assistant to the person performing the tuning. But there are no configurations. I mean, step fire, pulse fire, excess air modulated, everything under the sun, the certifier can help solve those problems for them.
So it could be no industry, for example, I assume aluminum industry, steel industry, heat treat industry, generally speaking, no problem firing into radiant tubes, no problem there. Right?
Yeah, we would. So, I mean, obviously, we're at the beginning of the launch of this product. So where we've focused on is direct fired heat treat furnaces and forge furnaces.
Okay.
And we're looking to branch out into other things. We've even had discussions internally of using this on resistive heaters for electric, because we know the green wave is coming, right? So So the product itself has been, I think, stated pretty well. The algorithm has no idea that it's even a furnace. It can be applied to pretty much everything. So I think this is going to be one of those products where we made it for this. We do this all the time with our burners. We made it for this, and then we find all these other ancillary uses for it because it's such a revolutionary kind of idea. Right.
Yeah. As you were talking, I was thinking to myself, yeah, if you've designed it so far for direct fired, to a certain extent, radiant tube applications might add a little more complexity to it, because you've got heat transfer rates through a tube. But I suppose still it's still gonna do the job, right? Because it doesn't know. It doesn't know.
Yep. There's a thermocouple having a response, and then there's this burner input, right? So the way the heat transfer happens is going to change, but you're going to have to modulate the radiant tube to get where you need to go. So
right. So it's a heat source agnostic, we'll call it. How about that?
Yeah.
Okay. How about a couple more questions? How about does the system have any type of reporting? I guess you did say, Ben, you said that when you after you do the first test, right, and establish the response matrix, there is some sort of a report, I assume, when you want to tune it. But what is the reporting? What's it look like? What are people going to get from this thing? And I guess I want to ask about the platform that it's on. I guess it's just PLC based, right?
Yeah, so the tuning is done through the PLC because it's communicating with those actuated bleed valves. The actual box itself, it's essentially a computer. So it's running our own custom code, and it's executing that to communicate with the PLC. And we've tried very hard to make it PLC agnostic so it can communicate with the most common things we see in the market today, communicate over common protocols like Modbus. It can communicate with Rockwell's Ethernet IP or with Siemens S7. So that is essentially just a computer. It's a Linux box that can talk all of those languages at once, so it can just plug and play with the PLC. The reporting we've tried to make look similar to what people are used to. So people are used to looking at chart recorders to see temperature. So we have essentially, a more advanced display of live data, chart recording for temperatures for valves, so that you can see exactly where it is, with historical data easily available at a click and drag, so you can see where it was, where it is today. As far as an output of the report, we've also tried to make that, look as much as possible like what people are used to seeing. So with the AMS certification, there's guidelines about what data needs to be stored, what needs to be reported. Yeah. And while we're not doing the certification, that type of time-stamped temperature by furnace ID, by who ran the test, all that information is generated in these reports every time that you do this response matrix, this training creation, and then every time that you solve that and do this tuning of the combustion system.
Thank you. Okay, so question is this this system, because I could see some people wondering about it. I mean, I do, so I'm hoping other people do. Is it cloud-based at all, or is it all basically it's on site, right? I mean, it's none of this is you're not
It's entirely on site.
Yeah.
Yeah, so there's certainly the option. I know some customers, although it's rare, but it is growing today, want their information to be more accessible than it is today. But if a customer doesn't want that, if they want everything restricted to the plant, if they want it restricted off of the plant network and even and just on the box itself, we can do that as well. So today, we don't have cloud connectivity built into the base box. We wanted to make it simple. We wanted to
Yeah.
make it easy for customer compliance. So it's an option. It's something that we can do, but it's not something that we wanted to pursue in the first release.
Right, right. And you're avoiding a lot of potential security, internet security, cybersecurity issues with that. So, all right. So one more, I got a forward-looking question for you, Justin. What do you think? You got this first one. I know you're just kicking it off. And by the way, I should mention, I'm sure by the time people listen to this, the AIST Tech show will be over because it's scheduled for next week, which we're recording this on the 10th of May, and it's scheduled for the 17, 18, and 19, I think. But I know that you guys are giving a presentation there, so perhaps we can reference that on this podcast, give a link for it. But I know you're just launching it. I don't know how long actually, when did you launch it? Has it been weeks, months, or a year?
I think it's been about a month.
Okay. All right. So it's relatively new. As I say, we're doing this on May 10th. So let's say April, late March, you've launched this thing. Have you put any thought into the future? I mean, do you have dreams and hopes? And if so, what might they be?
Yeah. So absolutely. We have some plans, some immediate plans. Obviously we've talked about the tiers and how we're going to keep pushing forward with making this a product that is for all furnaces, for all direct fired furnaces to start with manual valves and automated valves. So we'll get to the tier 1, 2, 3. And then a big trend we're hearing as we're talking to customers is more geared towards predictive maintenance. Obviously, we need to tune the furnace, but the customers don't want you tuning the furnace every time they need to certify, because that calls into question their parts from the last quarter or half year that they've been doing. So really you tune once and then you probably go a year, or hopefully on our furnaces, we go many, many years without drifting, right? But so the box can also be used for some predictive maintenance. Use the thermocouple inputs that we have to measure the box shell temperature, see if the fiber is degrading, see if you're up for a reline, see if your flows need to be readjusted. So there's a predictive nature to the retuning process rather than a reactive nature. So that's really going to be the next step. And then we'll look forward to see if there's other type of heating, like you said, radiant tubes or resistive heating. I think that's a little bit further in the future, mostly because we're obviously a gas combustion company. So we're focusing on what we know first, and then we'll build outward from there.
Right, right. So you're saying some of that stuff that you're hoping for the future is not really even combustion related. You're going to be doing condition of the furnace, like you said. Okay.
Right. Like a furnace health monitor, because we see that as I think everybody wants to know they're running that furnace pretty hard, especially in like a forge environment, right? You're beating the hearth pretty good. So to have a 1 month out, hey, warning, hey, you might need to shut down, rather than a catastrophic failure. We've gone into furnaces too much where there's been a hole in the roof or because the fiber fell out and they just didn't know about it, right? So trying to help customers out before something like that happens.
Yeah, yeah. Now, right now, I know most of all of these, I believe, correct me if I'm wrong, almost all of the burners, the stuff you're currently doing are all hardwired, correct? Is there any thought about making them a wireless? Is that even a reasonable thing to think about, or no?
From the burner standpoint or from the certifier standpoint?
From the certifier, in the sense of controlling and getting the data in and out. Maybe it's a silly question, but I was just wondering. I mean, right now you're hardwiring all this stuff. Is it? That's
correct. Yeah, we're all generally. I mean, that's currently the way furnaces are configured. Are all hardwired to a local PLC.
Right.
We have. I think Ben could probably speak a little bit more about it. I think we've talked about ways to wirelessly link devices more as diagnostic devices, really not controlling them you can't really control them wirelessly because I think the response time, but diagnostic components could be wireless.
Okay.
Right. And one of the first things that we did when the certifier was in pre-release was we were designing this box to essentially plug and be installed on that furnace. And we took a step back and we tried to consider, who's going to be using this? How do they want to use it? What do their facilities look like? And, a lot of people have multiple furnaces, maybe as little as 2, but sometimes, upwards of 20 furnaces. So maybe you don't want to install it permanently. Maybe you want to be able to move it around, or maybe if you have a plant-wide network and an intranet there, you can plug this in your control tower and you can sit in an air-conditioned room with one certifier and talk to every furnace at once. So that's something that we put into that release from a month ago. So the release certifier can communicate with all of your plant network at once if you have the plant network, or just with that one furnace if you want to plug it into just that one isolated furnace. So we should be able to, essentially, feels wirelessly, you can communicate to whatever's on the network at once.
Yeah. Good stuff. All right. Well, let's assume we've whet the appetite of or piqued the interest of people. Justin, where might people go to get some additional information? And feel free to give us much, of your personal information, your home address and your personal phone number and all that good stuff.
Yeah, for sure. So for some more information, our website is combustion.fivesgroup.com. And obviously Fives is spelled like my shirt, FIVES group.com. If you need more direct information, you can contact me, Justin.Dzik at fivesgroup.com. The last name is spelled DZIK. The D is silent. So, and obviously, like you said already, we'll be at AIS Tech next week. Probably will elapse this video podcast, but then we'll also be presenting, I'll be presenting at the IFC, International Forge Masters Congress in June, and with, I think, future engagements at Furnaces North America. So it's kind of on our road show this year. So.
Great. Well, you got a lot to talk about. And like I said, I don't know about you. I'm sure I know the answer to this question, but I'm going to ask it anyhow. I don't think anybody else has anything like this, for best I know. If they did, you'd be foolish to say so. But I haven't seen it. I don't know. Maybe they are. Maybe I'm going to catch grief for saying that. But it's an interesting new product, and I wish you guys well. I hope you're very successful.
Thank you.
Good to have you with us, guys. Thanks very much for joining us.
Thanks for having us.
We hope you enjoyed listening to today's episode with Justin Dzik and Ben Witoff. Heat Treat Radio is on Spotify, Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website www.heattreattoday.com/radio. If you'd like to get in contact with either of them, head over to combustion.fivesgroup.com or email Justin at justinzik, that's DZIK, at fivesgroup.com. You can also email me and I can put you in touch. My email is bethany@heattreattoday.com. Also, consider sharing a new or interesting idea that we can feature on a future Heat Treat Radio episode. Or if you'd like, think about sponsoring a future episode. Either way, you can let me know at bethany@heattreattoday.com. Heat Treat Today doesn't just publish podcasts. Get to know all the other resources Heat Treat Today has to offer. If you're enjoying the audio-video format, check out Heat Treat TV. Want more technical content? Search our articles on nitriding, parts cleaning, hipping, brazing, stress relieving, and more. Or just want to hear one person's opinion on a heat treat related topic? We've got columns and op-eds as well. All this and more is on heattreattoday.com. Heat Treat Radio would like to thank Heat Treat Bootcamp for sponsoring this episode. Find out how to enroll in this basic training at www.heattreattoday.com/bootcamp. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advanced written permission from Heat Treat Today. And I'm Bethany Leone. Thank you for listening.